All right, let's do this. Okay. Super important. Watch this. Okay. So I think we can all agree that rocks. Now we do have a problem. We can't run any of them over. Which kind of blows. But these ones we can. Okay. I still want to fix the ragdolls. The ragdolls are still super important to fix. But this is working, and that's really the important thing. And more important than that is that our FPS is not completely trash. So this is the one that was broken last time. So I need a loading screen. Is essentially what I've figured out here. But they're walking around. So we need a loading screen and all of that wonderful jazz, but the important thing is that it's working. And all we need to do is create a new, we need to optimize this so we can test it properly. So today's game is optimizations to get the pedestrians working correctly, because if I switch them over to the other ones, it causes problems. So what we're going to do is we're going to first, we're going to go test that and see if it's still a problem, because it was a problem, and we want to verify that it's still a problem, right? Because it's important. So, but we also need to have some system in place specifically for the crash. Like when we hit a pedestrian, it needs to feel different than hitting the target. And predominantly, they need to be lighter weight. And they need to die faster. Or they need to despawn faster. We also don't ever want to ragdoll them. So what we're going to do is we're going to go into characters. We're going to open up this. This is beautiful. Right here. We're going to make sure that we close the hittable character, because that's not important. Right? Then we're going to come into here and we're going to go down and reparent. And this will be TK hittable character. Right? Now this is really the problem here, but really all we want is we want to come into here. Want to go to collisions. This should not be generating these. And then if we go to truck, although like we might need to. So actually what we're going to do is we're going to get it working first. I don't think we need to generate hit events, but we'll do it anyways. Okay, there we go. Okay, so what we're going to do is we're going to go into here. We're going to start off with just them the way they are, right? Let's go to the mesh. What mesh are we doing here? Not collisions. We've got the mesh. Okay, so we've got the characters and everything like that. Play, right? And we're just going to simulate all of this in here. So we can see them. They're popping up. Can we run them over? Yes, we can. They don't simulate quite the same. Wow, they really don't simulate the same. It's because they don't have a pelvis bone. They do have a pelvis. They should not speed bump. It was probably because I was hitting the capsule. It was not. Oh, this is why. The collisions are not correct. That's all it was. There we go. Look at that. Now, okay, so the game thread is still fucked, right? And when we're running into these things, that's really where the problem lies here. Now, the issue is that these are all physics bodies, so they're all simulating all at once, right? We don't want that before they get hit, or we want multiple versions, right? So what we're going to do is we're going to take this to do Truckun. We're going to go to blueprints, AI, not AI, characters. We're going to create a new folder and we're going to call this pedestrians. No, actually we'll just do this because this is fine. So we're just going to duplicate this. No, we're not. We're going to create a whole new one. Force delete. That's fine. Blueprint, and we just want a character. And then we want a BP. Right? There. Then we want to go over to our AI again. Now it's the LOD, what is it? No, it's the visualization, right? And then we have low res template and high res template. So we're going to come into here. We're going to say characters, this, low. And the reason why this needs to be a low rather than just a regular is because we want this to be a Manny. Manny, no, Quinn. Quinn simple. And then location, -90. -90. Save, compile. Beautiful. So this one's doing nothing. Like effectively nothing, right? And then we just want this and we want to take tick. And we're going to want to turn tick off on everything. But first things first, we want to make sure that this actually swaps them out. So let's actually switch this to a different mesh, right? Because if we switch this to a different mesh, we can see when each one's being used. So we'll do that one here for that. And then for this one here, we want to switch it out with one of these schoolgirls. We'll do a sports uniform. Save, compile, and then we'll switch this out for walk. Walk in place. There, save, compile. Beautiful. And then when we hit play, we'll see both. Wow, Manny makes a big difference. Holy shit. An FPS difference for Manny, eh? Okay. Okay, beautiful. Now if we come into here, we want to go to this. For the low, we want a BP pedestrian low. And we can go into the blood params here. Was it blood params? No. This one here. High res spawn actor. We don't have a static mesh instance. So we're going to have to figure out where that static mesh instance is coming from. Because we see that, but we don't have a static mesh. I bet you anything, there's an error happening right now. Oh, that is super crashed. Oof. Oof. Stop. So so crashed. Yes, open this. Interesting. I almost feel like a pawn might be better. Yeah, where's the pawn two? We're gonna run this standalone game. Because we're gonna be running in standalone now since we've had problems. Okie dokie. I think it's a rotation. No. Yeah, here. So if I go to here and I do raw. No, that's the same. Huh. What is making this be different? We're going to open this full here, like so. Okay, that's about the same. Oh, it's because we don't have an animation. I don't want that. I want... I wonder if this will change it. I don't think so, but... That looked really funny. Okay, so there's a movement issue. Okay, so apparently that doesn't work. Or it's not going to work right this moment. Um, hmm. Oh, well. Crowd visualization. We need this to pedestrians. Yes. Okay. Sweet. Save. There we go. So we do need to keep it this way, unfortunately. High res template actor. Low res template actor. I think we're going to have to go do some quick research. Okay, so yeah, no, we're really going here. It's only when we're hitting lots of them that we're all at once that we're dropping frames. But I think that we can one up this a little bit better by fixing that. Yeah, so see, we're like right here, we're right around 60, and this will probably be better in a proper build, right? But when we go and hit people, we're going to go up in demands. But our draw frames are really good. So this all like physics calculations and whatnot. Thank you. We're going to try this and see if it works. The idea is to punt as much off of the main thread as possible, because then we won't have a a locking on the main thread. We'll have it potentially somewhere else. This is actually fucking so much faster already. Okay. That is something that we have to take care of right away. These should not be ragdolling the way that they are. So we go to characters. We're going to blow this open here. We're going to go into here. We're going to go to truck. Time to despawn 5. Let's put this down to 2. Actually, we'll put it down to 1. 1 seems reasonable. Then we're going to hit play. We'll see them. And as we smack into them, they will despawn. Obviously, like I said, we're going to have to do an actual proper load here. Because this takes too long. I don't want to be like doing that, right? I might be able to punt their, like right now, I wonder if their animations are not on a separate thread. Unreal Engine async animations. Multi-threaded updates. Okay. Oh, there we go. Okay, so they should be threaded. Disable post-processing blueprint. On init, should we set a to reference pose? False. Tick of animation data. So our goal is to get the high res, low res actors worked out here. Actor class of agent when spawned in high resolution. When spawned in low resolution. Okay, wait. I forgot to switch this. We wanted to do BP. Oh, wait. We're still on the same one. But what we're going to do is we're going to copy. We're going to make a copy of it. And this one we're going to do as Quinn. And this one I just want to do in here. Wait, I don't know why I did that. We don't want to do it in here. All right, I forgot to switch it. I do want a bigger standalone game. It's so warm. It's almost time for AC. It's almost time for the AC to come out. There's our pop in and out. That's not too bad, but we do need to increase it because they're switching a bit too. Yeah. They're switching a bit too late, so we still cause a problem of not seeing them. So maybe we do 5,000 for the medium. This would be 10,000. And this would be 20,000. And what it comes down to is it comes down to a loading. So because the pedestrian is somewhat loaded and it's held in memory, via the other girls, then we're mostly fine. Okay. Okay. They're not popping in properly. Because if I'm going fast enough, I might be able to like... Oh, no, they pop in it. Oh. Oh, that's cool. They'll dynamic... Oh, that's amazing. The visibility... I think it might be the visibility. So far, very happy. We are going to need to work out what's going on here, but definitely they do not need to have they don't need to have the same cloth physics, because I think the cloth physics are really what fuck with the system the most, is all the cloth physics stuff. Oh, that's not good. Yeah, no, it's still happening. Okay, so what I could do is spawn them differently and destroy the... I might be able to like spawn them as you hit, like spawn it, and then... Although like holding all that into memory would be a pain. Because like you'd have to pool that, and that's a lot of actors. Although they're just ragdolls. So they could just be pawns at that point. Uh, Because at that point, we're just worried about the head. They're already dead. Look at that, it's still destroyed. Yeah, no, it's just completely... Nope. I was hoping that would protect me. It did not. Oh, that's definitely a problem. So it doesn't like the switch. Interesting. Because the second we do that, we no longer have problems. So I just need to I need to figure out a way to make these things less intense. Look at that. Oh my God. It's so bad. It's really, really bad. The MS is huge. Okay. Um, that's mostly fine. If we do standalone game, we should be also fine there. Um, oh, okay, so like I think we're doing okay, but I don't think that we have enough AI at the moment. We do definitely need to switch out some stuff here to make these work a little bit better than they currently are. Because I think that we have a issue with tick, I think. Yeah, so like everything's ticking here. The pedestrians are all ticking. The pedestrians shouldn't be ticking. Why do they need physics ticks? Right? So what we're gonna do is we're gonna come over to the pedestrians here. We're gonna hit stop and we're gonna just go here and it's just gonna be tick. And actor with tick. Does the mesh need tick? No, no, it does not. Does the character movement need tick? It might. We're gonna leave that one on for now. These ticks do not seem to be required here, Auto. All right, we'll save that, and then we're gonna just remove these ticks here. There we go. Compile. Then when we hit play, we might have even better performance. We do not. It's fucking terrible. Okay, character movement, we're gonna do that, and there, save, compile. We're gonna try that again. Okay, they're still moving. Great. They should have no ticks now. My movement components are all ticking. Why are they ticking? Tick is supposed to be turned off. this is we're gonna move some stuff around here, and it's going to adjust how we do things, and I think it's going to be for the best. So we're getting rid of the capsule, the capsule, the capsule hit thing. Actually, no, we shouldn't. No, pedestrian should still be mesh based. It's gonna be faster. Like I think execution would be faster if it wasn't mesh based, but maybe we keep it mesh based. Okay, hittable characters. All right, so hittable characters. We want these to be the same, right? So we're just gonna do this. We're gonna do this. Actually, I'm gonna come back in here and we're gonna do one more here. All classes, TK, hittable character. There we go. There we go. Okay, so hittable character is the default here. I want to take this and I want to break this out into a function that we can just call, right? Actually, it's already there. So we'll do u function void on character hit. This one's the best. Move that in there. Okay. And then here we don't actually do the... What's the issue with this? Anyways, we're going to make some quick changes here. This is not right. So, okay, so what we want here is we want to have this set in a very specific way. Hmm. We're going to do that, and this is going to be on the target characters only. Go, and then this will be a public. Because it's not used at the moment. Uh, physics. Hmm. We're gonna do this. Wait, this should not be true. This should be false. It's already true. Okay, and then we're gonna do something very similar here. What's going on here? Oh shit! With the raid! Fuck! Things are broken right now. Give me a modem in here. Um. Uh. Let's see if this. Actually, no, it does work. It does work. Okay. Wait. This is where I'm at right now. We're working on performance optimizations. The sun beckons. All right, you have a good one. So I'm working on some optimizations right now, but this is where we're at. You know, um, those were all targets, and as you can see in the top corner, up there, every time I hit one, it goes down, right? And then these are pedestrians. They don't count as targets. You're not really supposed to hit these pedestrians, but you know, the targets are really the targets will get even cuter. You just wait. I can show you the work of the guy who's going to be making the targets. Um this is his work. This is the guy who's going to be making the actual targets. So he does good work. Let's see if we can find any of his older stuff. He doesn't stream very often. But yeah, so like he did this. So he's gonna be doing the targets. The pedestrians are as well. Yeah, that's what we were going for. But right now the FPS is a bit too low. So I need to performance optimize the targets because they're a bit they're a bit much. Oh, thank you for the follow. Much appreciated. Oh boy, I recognize that girl. You do? Is she from something? Or did you just recognize her from the Unreal Marketplace? Because that is totally what she's from. HXH? I'm not familiar with that anime. This is good. Got to kill them all. Oh, sup, Don. Uh, yeah. So if I actually run these girls over, I can show you what the we bam, and then let's run these ones over too. Once we get down to our lovely 0 here, these are the last two. There we go. And now I have control. Yeah, they're definitely getting there, and then we can replay this level if we want to. Whee! Yeah, things are getting really good. It's a good show, so I won't spoil it any further. Wait, by HXH, do you mean Hunter x Hunter? I don't recognize her from Hunter x Hunter. At any rate, she's probably not going to make it into the end game there. Oh, that's a weird glitch. The nav mesh broke, and now she's walking all over the place. Let's go. Let's run over the ones that escaped the nav mesh here, and whee. But anyways, so right now we're working on building out the city slowly. I'm gonna need 120 FPS minimum. Yeah, I'm working on it. Simulating physics though is fucking expensive. Especially with this girl, she's got a lot of physics issues. It's weird that they're drifting though. Like there's definitely a bit of a drift here where they're still walking the line, but they're not walking the line right. Come on, let me hit her. There we go. No, no, no. I ended myself. Wait, what? I found a bug. That's not supposed to be that window. Do you remember the name Kite? Kind of reminds me, it's kind of related to that. Maybe? Oh, maybe a tiny bit? Yeah. But at any rate, the pedestrians are gonna be a different color. So there's persona, right? Anyways, but um, odd Oculus, you've got to head out for the sun, right? I don't want to hold you up too much. Anyway, so what was I gonna do? Oh yeah, yeah. So Persona 4, I think it was. Or was it 5? It might have been 5. I think it was one of the more it was one of the personas had there was like a screenshot. Here we go. Something like this. Yeah, this one here. This is the one that I was thinking of. This is what I'm thinking of doing for the characters that you're not supposed to hit. So these will be characters that you're supposed to hit. These will be characters that you're not supposed to hit. Something like that, right? So they're going to be a little bit more basic. But that has to be made, and I don't have them made yet, so I'm just using this default anime girl one. Wow, the longer they walk around, the more drift they have. Holy shit. I wonder if it's because there's too many of them. I did put a lot of them. How many did I spawn? I've got 50 of them spawned in this tiny little area here. So what we're going to do is we're going to come down here and we're going to just move this here. So right, and then we just have them walk around this block and it will solve one of our problems. How was the rest of your stream, by the way? If you're still even here. You hate them? Are they not very good yet? Are they still broken as shit? They seem a little broken as shit. Could you have an internal clock signal that isn't aligned with computer clock? Like, I don't know. Might be asking too much. Small indie company? So if we just do this, maybe this will be better, and then we build zone graph. I don't like that it's static. I just took some of the CRUD processor code for a personal project and got rid of the zone graph. See, I think the zone graph is something that I'm going to need. Which is unfortunate, but it's going to it is kind of true, unfortunately. Because like I only want them to be walking around certain spots, and limiting that in the default system is not going to be super great. Because like I thought about just using like the one of the default controllers, but I was like, I kind of really like the new state tree over the old graph. Oh yeah, there we go. I think there's a way to make them yeah, because for the most part I just want them to like walk along the graph, right? I definitely have to turn this up, and I think that we need to figure out a way to not have them walk in a circle like that. But we do need to turn this up here. Because 50 is not enough for that. Oops. Let's try it out, boys. Yeah, there we go. Look at that FPS drop. These girls are so heavy right now. They are very heavy. Yeah, we're not going to use procedural city or anything like that. We're going to handcraft it. Or I should say I'm going to handcraft it. Holy shit, my FPS is just tanking. Yeah, that's definitely a problem. Oh, right. I need to turn off nanite and lumen. Don't want that. What? I am not familiar with that. I'm not sure what that is. Okay, so the idea is that there's going to be like maybe a maximum of 20 or something like that, or whatever, of these actual girls walking around, and then everybody else is just going to be one of these. And right now, the ones that are on this path here, these AI here, they are they're the AI. They're the pedestrians that are going to be these multicolored shaded things, right? And so they don't need to be special. Which stream? Today's stream? I'm just working on the mass AI system. Good old Truck-kun with mass AI. I need to go in. There was like no performance regards for the current pedestrians or the targets at all, because there was really no need for it. Oh, I did ask. Um, how did the rescue? How did your stream go today? Did you get lots of roasting in? I lurked for a little bit, I think, on like YouTube or something like that, but it was a pretty it was a pretty busy day at work, so I wasn't too active. But goddamn, this FPS is killing me. Whee! Okay, I should probably actually get back to work here. So what I was doing when you guys popped in is I was extrapolating things out to make the pedestrians more performant, because right now they're relying on some extra logic that that the right now the collision is happening on the mesh, which mesh collisions are substantially more expensive to compute, especially for a mass number of characters. So we're going to switch that, and then we're going to apply the physics calculations to them. But at the end of the day, I don't even know if they should ragdoll properly, right? Like ragdolling them properly doesn't necessarily make sense. So we might go into Houdini and performance optimize that away. Yeah, I think I roasted someone saying you need to grind elite code, or other than that, they roasted my performance. Uh, my preference of grape jelly on pizza. That is a combination I've never heard. Wait, what's the pizza base? Is it like a pepperoni pizza with grape jelly? Just so you know, you can't buy grape jelly in Canada. You get grape jam, but you can't get grape jelly. At least I've never been able to find it, because I actually went on the hunt. I was like, I want to try a proper traditional peanut butter and jelly sandwich. And a traditional peanut butter and jelly sandwich is, I think it's Skippy peanut butter, which I can't get, and um, grape jelly is the official traditional PB and J. Okay, let's see how broken this is going to be. I'll have to take your word for it. since I can't actually try it, you know. If we come back to here, there's a bunch of things that we don't need anymore. Speed bump, we're going to put this as false, but I got to figure out which one is actually being used. Yeah, and then what about this one? Okay, enable character speed bumps. This should be false by default. Yeah, pepper, Grape jelly just doesn't seem to be available. Mesh be an overlap. We need this one entirely copied up here. Realistically, this should actually be be a function of its own. Let's do that. Void I'm not entirely sure what information we've got to pass into this. So what we're going to do is we're going to copy over the mesh data here. And then we're going to paste it into here and it's going to complain. And then we're just going to add to it. So other actor we'll bring over, which is an A actor. That's fine. And I think that's the only thing that we care about. So yeah, that's a thing. Okay, and then we should be able to come down here and this character hit other actor. I almost want to change this name from character hit to launch character. There we go. That feels better. There we go. On character hit. This is character hit ground, right? Oh, this is just not used at all. What does this even have in it? Oh, this is like another launch code here. All right, we're getting rid of that. This does not need to be there. There we go. Then we want yeah, that's what I thought. So if we hit the character, if speed bumps are enabled, the despawn timer is started when they hit the ground. Oh, this can be an else. There we go. Where is this being used? It's not. Okay, sweet. Oh, that's where it was being used. Okay, so this get mesh. We want no collisions. Actually, we're gonna leave that just for now. And false. Uh, um, oh, that's interesting. Didn't know about that. All right, we're gonna leave this like this for now, and just hit play. Now we've moved some things around. Let's incrementally test things to see what's going on here. Oh, target? Nothing's using this right now. just... How's everybody's day going? Did you change anything about the loading system they had? Oh wait, I totally missed some stuff here. Did you change anything about the loading system they had? I have not. At least make them look... Okay, I totally missed something there. I'm sorry. Now I feel bad. Okay, let's make sure that the pedestrians are still working. We'll make sure that the pedestrians still work, but we'll also need to make sure that the targets are still working before we migrate the targets over. It happened. It happened again. God damn it. What's your favorite tea? Oof. That's a hard one to answer. I not looking forward to this. I think I have to scrap the fuck. This seems to always be the problem. Yeah, look, they're walking all over the place now. The second that happens, they lose track. God damn it. It's black tea. I drink usually black like an Earl Grey or a green tea are my two kind of go-tos. Although now I kind of want to have a tea. Good luck, Pseudo. Oh, thanks. I might have to do old school stuff now. Fuck, I really didn't want to. Actually, I wonder if yeah, I don't mind the I've got no strong preferences to or from it. It's just it's an easy tea. I wonder if I can use these the zone shapes without mass. Ooh, what are white? What's a white tea specifically that you like? Ah, that makes sense. Mm. So wait. Zone shape. It is a zone shape, right? Yeah, zone shape. Um, zone shape without mass. Hmm. I'm very disappointed right now. This is killing me. Every time this kills me. This causes so many problems. Let's see if it does it every time, though. Okay, it didn't do it that time. Let's just make sure that things are still working. Okay, things still work. I think my FPS is actually worse. All right, well, this blows. The mass AI stuff, I think, is just too early days. It's not going to work. Which really upsets me. I want these graphs to work. I want to have these zone shapes, but with a hand roll, like a more customized, without using mass AI. So let's see if we can do that really quickly here. So we go into characters. I don't think that we can though. Let's go to no, we'll put this one in AI. Blueprint. Grid path AI controller. I've not seen that one. Grid path. Unreal Engine grid path AI. I've used it, but I'm looking. But from look, I've never used it, but looking at the only thing it does is replace the default path following component with a UGrid path follow component. And the remarks in the doc are path following argument with local navigation grids keeps track of nearby grids and uses them instead of navigation path when agent is inside. Once outside grid, regular path following is resumed. This allows creating dynamic navigation obstacles with fully static navigation, a static nav mesh, as long as they are mirror modifications for paths, not recommended for blocking off entry corridors, does not replace proper avoidance for dynamic objects. This allows creating dynamic navigation obstacles with fully static navigation. Static nav mesh, as long as they are mirror modified. Interesting. I'm kind of curious. We're just going to take a quick look here. Hmm. This is new. Maybe? Maybe not. It's new-ish.
Generation type enumerator also have controlled via the roof builds one by one, making sure that our FPS is a lot more stable than it would be otherwise.
That's cool. All right. That's unsurprising. There's this one. This is like the ultimate piece here because it's using an entity component system, and then you can like drop a bunch of stuff, right? Unreal Engine.
Hello and welcome to Unreal Engine 5. We're going to be talking about a new system implemented in the engine that provides the foundations for having huge numbers of agents simulated in real time. It is a framework that was initially designed for the Matrix Awakens demo and used for AI simulation in that context, but in fact, it can also be used for other gameplay purposes. The MAS system makes use of efficient data-oriented design processing on tightly packed data so that we can scale up the number of agents in our worlds. Right now, it is mostly something that has to be used by writing C++ code, but there are some elements in place that can be done in Editor and that will be extended with future versions of Unreal Engine 5. It is also a feature under heavy development, so some of the names or workflows displayed in the video may vary as the new versions come, but with the information contained in this video, you should be able to start working on your own scalable systems with thousands of agents. For those that are not familiar with the term data-oriented design, let's do a very brief explanation. Current machines have a performance dependency on how memory is accessed and manipulated. Data is usually scattered because ease of code has been a primary focus over efficiency. So a different approach is needed to really get the most out of modern hardware. Since cache memory is orders of magnitude faster than main RAM, cache misses should be avoided, and our architectures should have that into consideration. Processing contiguous data that fit entirely in cache is the focus of a data-oriented design. Instead of storing and processing one individual with all its components at once, MAS is going to pack all the similar data for all the agents at the same time. How does the MAS framework actually implement data-oriented design? MAS will manage different agents that are called entities, and those entities are going to have a collection of traits. We can think about those entities as lightweight actors, and the traits as lightweight components. This is not 100% true, since neither entities nor traits have functionality, and are only defining identity and data respectively. Entities are going to be defined by a list of traits, and that definition is called an archetype. The real data is going to be stored in fragments, small extracts that define the state of a given functionality, again, like the data of a component. While the actual functionality, the evaluation, and the alteration of each fragment state is going to be implemented in processors. Processors are going to filter the entities that use the data they can operate on, and will be served the fragments of those entities packed in chunks, all of the same type at the same time, facilitating the manipulation of the same kind of data in sequential and contiguous blocks, making cache misses less likely to happen. But it is going to be better to explain it with some examples, so let's create some entities from scratch. To have access to the MAS system, we will be required to enable certain plugins. MAS Entity, MAS AI, MAS Gameplay, and just in case, MAS Crowd. After restarting, we will find that we can create a new data asset called MAS Entity Config Asset. This data asset will allow us to define our entities, assigning traits to every entity defined there. As you can see, there is an array of traits that will define this entity's behavior. Let's start by adding the debug visualization trait that will render the entities in the scene while in Editor. Some of the entities will have properties that we can modify to change their behavior. In this case, we can change culling distances, the wire shape, the mesh, and the material. Let's assign a cone mesh and leave the rest as it is. Now we have to be able to spawn entities defined by this MAS Entity Config Asset, and for that, there is an actor called MAS Spawner, where we can define how many entities to spawn, the MAS Entity Config Asset to use, and how we are going to be generating them. For now, let's say we are going to spawn 100 entities of the MAS Entity Config Asset that we just created, and select Environment Query System Spawn Points Generator as generator instance, since we are not going to be talking about zone graph in this video. We will generate a new environment query for this purpose, and inside it we just create a new node, Simple Grid, to query the system to generate random points in a nearby grid. Let's set the grid half size to 5 meters. After checking that the auto spawn on begin play is ticked, we can try and see our entities playing in Editor. As you can see, our entities have been spawned in the map, but they have no functionality so far, so let's write some code. We will start creating something really simple, like moving to a random target in the world. At this point, we will have to jump into C++, since currently there is no way of defining fragments, traits, or processors in Blueprint. We can go to Tools, New C++ class, and though we can't select fragment as a new class, because it is a struct, we can create a new trait, inheriting from UMass Entity Trait Base. This is going to be the code that will be generated, so we can start defining our new trait. We're going to create a very simple random movement around the origin, and for that, every entity needs to keep the information of their own target location. As explained, when we want entities to have state data, that is built using fragments, so a new fragment is created using this code. As you can see, we are inheriting from fmass fragment, which is a struct, and we are just adding a vector to it. That will be a valid fragment already, no functionality, and the data that we want every single entity to store about themselves. But to attach that information to our entities, traits are used. So we are going to add that information to the build template virtual function of the newly created trait. We're going to use the add fragment method from the build context to tell the trait to add our fragment to the entities. And that is basically what a trait is going to do, assign fragments to entities, shaping up the functionality for them. And now, to be able to do something with that target data, like moving the entity around towards that target, we need to create a new processor. There are several types of processors, but here we are going to implement the most common one, a UMass processor. It's going to look like this, with three key methods: the constructor, configure queries, and execute, and an entity query to request processing operations on the data. Processors are unique systems that are usually auto-registered, so as soon as we define one, the mass system is going to ensure that there will be a processor instance for our entities. And just one only instance is going to be processing all the data from all the entities in the level. In the constructor, we define how the processor is auto-registered and what is going to be the execution order. Bear with me for this example. We are auto-registering the processor, so an instance is generated automatically for us. And then we define execution to happen before the avoidance processing group. And after that, we get to one of the most important bits of creating a processor, which is defining what entities are going to be processed. And for that, we can do it in many ways, but usually we're going to add fragment requirements to it. In this case, we want to process every entity that has a transform and our simple movement fragment. Here we could be adding more requirements that have to be fulfilled, like having a given tag or not having a given tag, for example. We're going also to define how we will access that data, if it's read-only or read-on-write access. And finally, what we are going to do with the data is defined in the execute method, where we will be using the entity query to iterate over entity chunks. For this example, we are not going to be using a parallel for, because that needs several extra considerations that are out of the scope of this video, like whether we are operating over thread safe data, for example. Instead, we are going to be doing a for each entity chunk that, since the data is going to be tightly packed in memory, anyway is going to be highly performant. This loop is going to go over all the chunks of entities that fulfill our requirements. And in here, we are going to access the different fragments as array views, instead of entities individually. And here is where the data-oriented design comes into place. So we will iterate on all the entities in the current chunk by going through all the indices. Be aware that these indices don't identify uniquely your entities a long time, since chunks disposition may change and an entity that has an index this frame may be in a different chunk with a different index the next one. And now we write the code that will make our entities move. First, we grab information from the transform and target fragments. We subtract them to know the vector that goes from our current location to our target location. If the size of the vector is less than 20 centimeters, we are already there, and we generate a random location within a box center in the origin and with 20 meters on each side. And we store it back into our fragment, so this entity will have that new location as target movement. But if we are not there yet, we will move our entity towards its target by getting the current location and adding the target vector normalized and multiplying this by some speed and by the delta time. We extracted the delta time from the execution context. Let's compile and jump back to the editor to add the new trait to the entities. We have to do nothing for the processor to be instantiated though, since we have set it up to be auto-registered already. And that will be all. We can now try this code and see the results. As you can see, each entity is moving independently and with a different target to move to. Notice, though, that the first target for every entity is the origin, since we can't specify something random for the first iteration without adding some extra code. But we will see how to do something similar in a moment. Before jumping into a more complex example, let's try to increase the number of entities to 10,000 and see how it behaves. As you can see, it is still holding up, more or less, with such a big amount of agents, though the frame rate is not playable. But we will see later in this video how to make it scalable for so many entities. Wrapping up this example, ideally, we would be operating only either on the targeting or in the movement, but for simplicity, I group both things together in the same processor. But we should have had two of them, one that only cares about moving the entity, reading but not writing the target information, and another processor that updates the target when we are close enough, and only reads from the transform without modifying it. Once we have seen how to build our fragments, traits, processors, and entities from scratch, let's talk about a more complex example. In this simulation, you can see I have some agents that are building their homes, and for that, they have to gather two resources, a piece of wood and some stone. To achieve that, they will be looking for the closest resource, spend some time gathering it, and come back to their homes to keep working on the building. This also involves some complex systems, like avoidance among them and other elements in the world, height calculation, claiming resources, and so on. But let's dissect some of those things first. For this example, I created some custom traits, starting with the builder trait, which is going to have fragments for knowing what is the next floor to build, or where the actual building is in the grid, but also the current state of the builder, to know whether a particular entity has to gather resources or go and work on the building. The harvester trait that holds fragments to know what resources we have gathered already and where to find the next one, and many others. You can probably imagine what these traits with their corresponding processors are doing just by reading the name, and explaining all in detail is out of the scope of this video. But let's talk about the peculiarities and different tools, besides the already explained basic elements, that can be used to develop our systems. First, there is a special type of processor that is worth knowing about, the mass observer processor. This processor is going to help us to initialize fragments that depend on other fragments information or other systems that may not be initialized.
Does he not actually give any? No, he doesn't. To be fair, this almost looks like, yeah, no, he doesn't. Wow. I'm unsurprised. There is, Tickle Epic, here's this thing we want to show you, but shut the fuck up. If you need help further, I'm done. Can I get my bonus now? Very epic employee. Yeah, sounds about right. Don't get me wrong, what the fuck? When did I buy this? I straight up don't remember buying this. This has to be something that was free. Sorry. They have this one here. I think this actually is using it. But oh no, it's available. Hey. This might be a way to do it. Let's try this out. Let's take a look. Let's see if this one does it. Or nah, don't create. No. We shouldn't. I'm getting some good info here on this.
At construction time. I have one to adjust the radius for the avoidance of some of my entities in the building simulation. The agent radius belongs to the F agent radius fragment and has a default value of 40 units, but I want to change it for the builders and only for the builders. To create the initializer, I have to inherit from UMass observer processor and override the same functions that we overrode in the previous processor example, configure queries and execute. We can also see that the registering process is different. Instead of stating execution order or registration, we define the type observed. And that is the only difference with a standard mass processor, since the code for execute is going to be really similar. We just have to acknowledge that this is going to be executed just one time at the beginning. You can see the initialization code there for the agent radius. Another use case and scenario, an observer processor could have been used in the simple movement example to assign an initial movement target, instead of having the origin as the initial target. Like for example, the current location, so in that way, the movement processor will have branched to finding a new random target automatically. In the agent radius initialize, you may have noticed that we had a tag as a requirement in the configure queries method. Since processors will iterate over any entity that fulfills their requirements, we will be facing at some point that a processor is acting on an entity definition that we don't want to be processed in that way. So we need an extra filtering definition to avoid having empty fragments, just for the sake of filtering. That will be the case of our agent radius initializer, since without the tag, every entity with an agent radius would pass the filtering. So a mechanism for filtering out different types of entities, even if they share the same traits, should exist. And that mechanism is tagging. Tags are easy to create and work with, not only to tell what entities we want to include, but also what entities we want to avoid. So instead of specifying all in the requirement, we could say known, so no entity with that flag will pass the requirements. A good example of the use of tags to exclude certain entities will be also the LOD system that we will see later in the video. Now, let's look at how we are handling positioning for the workers and for different elements like resources or buildings. I have implemented a grid to represent the world, where each cell is going to be 2 by 2 meters and can contain either an empty ground, a building with the builder's ID associated, resources, either a tree or a boulder, with a number of slots associated to the current gatherer's ID. It is a plain two-dimensional array that lives within a subsystem. Subsystems are automatically instance classes whose lifetimes are managed for us and are easily accessible from almost anywhere. So this grid subsystem is going to be reachable from our processors, where they can ask for the location of resources or the height of the current cell, and caching the pointer to the grid subsystem in the relevant processors and grabbing the actual system in the initialize virtual method. But we have to be very cautious about memory in this regard, since accessing every frame to this grid for each entity would cause a big impact, because it will likely mean random memory accesses. Meaning that we will have to ask the main RAM to fetch the data for us, because it can't live altogether in the cache, along with the fragments that we are currently iterating on. To palliate that, I'm storing a subgrid of 3 by 3 cells in the movement target fragment. And only when an entity is outside its cached grid will request new data to the grid subsystem. That will save us many cycles every frame, since knowing if an entity is out or not from its cached grid doesn't need any data from the grid subsystem itself. If you have a look at the already existing processors in the MAS plugins, you will see that they also make use of subsystems, like the MAS navigation subsystem. And talking about already existing processors, it is good to understand those that already come with included plugins, because it can make our life easier. For this project, I'm making use of the applied movement, smooth orientation, steer to move target, and avoidance processors, among others that you can find in the MAS AI and MAS gameplay plugins. The built-in movement system works by updating the values in fmass move target fragment, and the already mentioned processors will work out the displacement. So, to make use of this built-in movement, the values in the fragment that we will be modifying are the following. Center would be the target location we want the entity to reach. Forward is the desired facing vector. Distance to goal is self-explanatory, is the distance to our center. And slack radius is the threshold to detect that we are at our target without actually being there but close enough. When we want to stop moving and start doing any other task in place, like in my case, the builders chopping trees or working on a building, a different action can be created using the method create new action. Anyway, implementing something that modifies the mentioned data and fulfilling the requirements of all those processors would be enough to get our entities moving around. So, a very simple implementation of movement using this framework will be the following processor. We're going to register it in the same fashion as we did with the simple movement processor. Then we ask for the requirements, and here it is where we can see some differences. We are requiring the mass move target fragment, but also a shared fragment called mass movement parameters. A shared fragment is the data that is going to be shared among all entities of the same type. In this case, the shared fragment defines speed parameters. And in the execute method, we are just going to update the distance to goal and the forward information in the move target fragment and set up the new target once we are close enough to the last one. And that is enough. Along with adding the movement, steering, avoidance, and navigation obstacle traits to our entity definition, we have now proper movement implemented. Adding the movement, steering, avoidance, and navigation obstacle traits to our entity definition, we have now
Really, that's it?
with adding the movement, steering, avoidance, and navigation obstacle traits to our entity definition, we have now proper update the distance to goal and the forward information in the move target fragment and set up the new target once we are close enough to the last one. And that is enough. Along with adding the movement, steering, avoidance, and navigation obstacle traits to our entity definition,
Hmm. I have an idea. Sure. Let's see what we can remove here to and still keep the system working. So we might be able to get rid of assorted fragments. The capsule collision sync thing, I don't know that we need. We don't need that. Don't need that. We want the crowd member and crowd visualization because that's what we're going to use instead of debug. Then we want movement, steering, avoidance, and navigation object. And state tree. Although I think the state tree thing is actually going to cause us a problem here. There's our zone graph navigation. Steering, movement, avoidance. And we've got the state tree. Okay. Now, I think all we need to do is add in, again, the mass, whatever. Then this is probably going to crash. It straight up did not actually even spawn a single unit. Oh, wait. We'll say 100. What? What's the requirement? Unreal Engine victory. Hmm. Unreal Engine state tree required traits. Mass actor fragment. It's probably that. This spawned nothing. So good. Okay, so they want to transform and an agent radius. Oh my god, it worked. There's still this. I like how it doesn't actually tell you which one it's missing. Ensure condition. But I imagine it has to do with an orientation one. This is a bit better. They're not avoiding. I wonder if destroy is the right thing to do. What we're trying to do is figure out if they're going to start walking all over the frickin' place. Okay, so they're not avoiding obstacles. Okay, okay, okay. So we need another one. We're at least getting somewhere, right? Navigate obstacles. I feel like I've just replicated everything that I already had. I don't count as an obstacle. And all we want to know is, are we going to cause that error from happening? There we go. Look, we already have one person off in La La Land here. Same with her. She's off in the wrong section here. Actually, this might have to do more with like tweaking settings. Maybe. At least we're getting some. We're a little bit better off right now than we were when we started.
We have now proper movement implemented. For simplicity, I'm adding an additional condition for the entities to look for another target, which is that our target is the origin, so I don't need any initializer. An interesting thing is that we could add some entities that don't move but have the navigation obstacle, so every entity using avoidance will consider them for the calculations. And that's what I'm doing with the trees, boulders, and buildings in the building simulation example. At some point, we're going to want to interact among entities or with the external systems. In this project, the builders generate new instance static messages when adding parts to their buildings, and for that, they are communicating with a subsystem, dropping messages in a queue. That queue is a basic array where I'm adding those messages, and the subsystem will be processing all those petitions and adding instances to the proper instance static mesh components. Another way to communicate with the gameplay framework will be through the mass agent component, which provides a nice way of adding entities to actors so that they are considered as such. In the entity config, we can add agent-specific traits and decide if the information is going to be synchronized from the actor to the mass system, from the mass system to the actor, both ways, or only for initialization. But the full list of traits is also available for the mass agent component. If we look at the building simulation, we could notice that not all the builder agents behave in the same way. In fact, at the far distance, they stop caring about avoidance, and will calculate height in a simple way. Instead of predicting height interpolation, they will just roughly calculate the current height. And this is because of the LOD system and the variable ticking rate. With the simulation LOD trait, we can set different tick rates depending on the simulation LOD, and their variable tick params and tick rates. To make use of these values in our processors, instead of reading from the wall delta time, we have to extract the variable tick delta, like in this piece of code. Also, we can define the distance at which an entity is considered of a certain level of simulation LOD, and which is the limit of entities per level. Internally, the LOD uses tags to filter out the farther levels or to select simpler functionality for them. We can see here how we can set up different functionality in our processors for different levels using different queries with different requirements. Or, like in here, we can filter out the more distant entities from certain calculations. So this system is the other key to scalability, since it will allow us to leverage the amount of code we run. And in this case, it allows me to reach almost 100,000 units processing different amounts of code at different ticking rates. To make it work, in our entities there is an additional trait called LOD collector, and be sure to have the mass LOD collector processor registered. To do so, we can go to project settings, look for the mass section, and there is a mass entity processor CDOs, look for the mass LOD collector processor, and check the auto register with processing phases box. There is another system already built in, that is the visualization. If we look at the visualization trait shared fragment options, we find that we have the option of using a static mesh instance or actors. For the building simulation example, I'm using only instance static meshes, since I don't expect the camera to get close enough to the agents. But for a project where the camera can really go close to characters, it would be better to have a high and low actor version and mix that solution with the static mesh instances. But we will focus on the instance static meshes implementation. We have to select a mesh and be aware that if we want to pass any custom data per instance, the mesh can have NANITE enabled for now, though that may change in the future. The visualization processor needs some fragments that are not added in the trace that we are using, and that's why we have a trait called assorted fragments that allow us to add specific fragments. In this case, we're adding the mass viewer info fragment and the mass actor fragment, in case we want to have actors visualized. I'm using per instance custom data in my materials to 1. Select the different available textures from an atlas, and 2. To play the animation in material, since the different animation sequences have been baked into textures in a per bone basis, and are played in mesh using that information without the need of a skeletal mesh. I have used a plugin called Add into Texture that is available in the City Sample project that has been released with Unreal Engine 5, but probably will be available in the engine in future releases. If you want to know more about this technique, there is a talk that has been released with that information without the need of a skeletal material, since different animation sequences have been baked into textures in a per bone basis, and are played in mesh using that information without the need of a skeletal mesh. I have used a plugin called Add into Texture that is available in the City Sample project that has been released with Unreal Engine 5, but probably will be available in the
Sorry, I had to go check that out.
engine in future releases. If you want to know more about this technique, there is a talk I gave at GDC called the Illusion of Motion that is available on the internet. The plugin basically takes a skeletal mesh, an equivalent static mesh, and a list of sequences and generates the textures with the weighting information as well as the bone rotation and translation, and also prepares the material to be able to reproduce it, as you can see. It is not on the scope of this video, but I didn't want to wrap up without mentioning that there are numerous tools already built in to extend the functionality I've been talking about. There is a mass crowd plugin in the AI folder that is specific for creating crowds in your projects. Also, state trees have been introduced into Unreal Engine 5, and they connect pretty easily to the mass system. Just by creating one state tree asset and selecting it as schema mass behavior, we are going to be able to control entities' states through different tasks. Tasks are going to be as processors, but that output a result to the processing of the fragments so that a new transition to a state can be evaluated. This is a cleaner way to handle state for our entities, and also it can work in a level of abstraction where less technical team members can feel more comfortable. Tasks for the mass system still have to be defined in C++, but tasks for actors can be created in Blueprint in the same way that we can create tasks for behavior trees. So, as you have seen, the mass system is quite ready for you to start building scalable behaviors with great numbers of agents. It is built among many different pieces, but that makes it flexible for many situations and needs. I hope that this video has clarified the possibilities of the mass framework and provided you with enough tools to start experimenting with it. I'm
Not
really eager to see what you can
really.
do with these tools and those to come in the following versions of the engine as the system evolves and grows. It will be something massive and epic for sure. Just don't forget to join our new developer community and don't miss the videos my colleagues and the rest of the community members have already created and shared there.
Oh, I'm hoping that 5.4 will have some fixes. Oh, custom. Interesting. Oh. Okay, let's take this and take a look at this. It's 2 years old. Some of it's going to be not that relevant. Okay, so let's take a look at what he did here for his trade. This is mass processor thing, right? Hmm. We do this. Execution flag. Oh, this has the avoidance. Oh. There's a mass move trait fragment? Huh. Mass move target. I wish there was more details on the different traits. Oh, sorry. I want to process all entities with mass move fragment. Hmm. So, I don't know. This seems interesting. We kind of got most of this in. This, I don't know. I'm not gonna lie, I am fucking exhausted today for some reason. I've been exhausted for a while now. So pre-animating their bones is probably the right way to go. Fixing them so they're not collisions like the way that they are is probably also the way to go. They're not avoiding each other. Hmm. Okay, so we're going to start with truck. Then in here, we're going to say we want no collisions. Yeah, that's to be expected. This doesn't need to generate overlap events. This one here does. Then we're going to go to the collisions here and we want vehicle overlaps. And that's really all we need. Why is that happening? Oh, wait, because these are pawns. What's Truckcoon collisions at? Pawn is supposed to be overlap. Physics body should also just be overlap. Okay. What the fuck was that? Look at her. She's wandering off into La La Land right there. Oh, wait. I think I know why. This should just work. The capsule should be generating overlap events. Capsule overlap events. Ah. think I might just call it a day. Yeah, I'm pretty tired. I'm going to call it a day and figure some stuff out. I will catch you all later. All right, ta-ta for now.